Hello everyone. Today we discuss source inductance effect on single phase converter. These source inductance mainly because of the source impedance as well as transformer leakage reactance and transmission line inductance also. Okay, so we can take it is a combination of those three inductances, and because of these inductance, so current computation from one set of devices to another set of devices, current transition from one set of devices to another set of devices will not happen instantaneously. If we redraw this circuit, and circuit will look like this, we have connected source as well as source inductance in between node A and B, and this is the current direction which is flowing from node B and node A. And this one is supply voltage Vs and voltage across inductance VL, and in source inductance value LS. Clear? And current flowing through these converters, let us take this is I2 current and this one is I1 current. Okay. Now we can say that these two currents are equal in magnitude. So I1 which is equal to I2 current. And similarly, current flow through third device, third thyristor and fourth thyristor. So this is I3 current and this one is I4 current. And also we can say that these two currents are equal in magnitude. So that is I3 is equal to I4 current. Clear? And then if we apply KCL at node X and node Y, you can say that I0. So here I0 current is constant current. We have considered that this load is highly inductive load, and it is almost assumed, we are assuming that it is almost a ripple free current and constant current in magnitude. That is I0 current. Output current is constant in current magnitude. That magnitude is I0 amperes. So if we apply KCL at node X, then I0 is equal to I1 plus I3, and at Y, I0 is equal to I2 plus I4. Okay, so these two are equal in magnitude, then we can directly consider that I0 is equal to I1 plus I3, I1 plus I3 are I2 plus I4. Okay, so these two currents, whatever it may. Now, and one more thing we need to consider, that here power delivered by supply, which is equal to instantaneous power I'm talking. So that instantaneous power PS is equal to Vs into Is. Okay, power delivered by this supply PS is equal to Vs into Is. If this is positive and it delivers energy to the load, source delivering energy to the load, so we can say that it delivers power to load. Clear? And for example, if this is Vs and Ix product is negative, if this is negative and it is absorbing power from the load, Clear? Now, here in this case, this is supply sinusoidal signal, and this one is gate triggering pulses. So at alpha instant, at this instant, we are giving triggering pulse to thyristor 1 and thyristor 2. Okay, so these triggering pulses are 1, 2 related triggering pulses. Okay, and we'll give triggering pulse, gate triggering pulse at this instant. That triggering pulse is related to third, fourth devices. This triggering pulse related, and this is similarly same thing. Every cycle will continue triggering pulses. So that is 1, 2 triggering pulses, and this is the firing angle. We are giving triggering pulses at firing angle alpha. Okay. And I0 current, we have already assumed that I0 current is constant current in magnitude. So this current is constant here, and that magnitude is I0 amperes. Okay, and then Is So we are assuming that before giving triggering pulse to 1 and 2, what are the devices are conducting? So before 1 and 2, device 3 and 4 were conducting. Okay, if 3 and 4 were conducting, then I0 current is equal to I4 current, and that is equal to I3 current. Okay, and we need to apply one more thing here. What is IS current? Here the IS current, you can apply here IS current is equal to IS plus I4 is equal to I1 current, right? So from that expression I'll write IS current is equal to I1 minus I4. Clear? Now this I1 current, so before triggering pulse 1 and 2, so I1 current is 0 amperes. So that what is IS value? IS value is equal to minus I4. But I4 current is what? I4 current is I0 current. So in this case, what we get means this is I0 current. Okay. Now here this current is what? This current is minus I0 here. And after that, what happens means we have given triggering pulse to the thyristor 1 and 2. Okay. So if we give triggering pulse to 1 and 2, these two thyristors will start conducting. If these two thyristors are started conducting, then this load current is having two different paths. One path is it can go through T2 and T3. Why? Because it was already in conduction mode. Or it can go through T2 and the source and T1. So this is the combination. And another path is T3 and T1 or T4 and T3. So these are the different paths for I0 current. But which path this I0 current will choose? I0 current always chooses, this is the priority. So current load current always chooses to supporting path. The supporting path means these paths should deliver energy to the load, that is supporting path, path number 1. Another path is it chooses to zero opposition path. For example, if it chooses to this path, okay, from T and T3, T2 and T3, so that is zero opposition path. Okay, so it chooses second priority. And otherwise T1 and T4, it is also zero opposition path. This path will not consume any energy or it will not deliver any energy. Okay, so fine. So this is zero opposition path. Another path is opposition path. Opposition path means, for example, if it chooses to T3 and T4 devices, these two devices, in these path what happens means, if current is flowing through this direction, so in that direction the source is consuming energy. That means load has to deliver energy to the path. Okay, so that is what happening here. If we clearly notice, before alpha, current IS is negative current magnitude. This current is here negative current. This is minus I0 current. So if this is negative current and this voltage is positive voltage, so positive voltage and negative current, so product of these two values will give us what? So negative value. If it is negative value, source is absorbing power from the load. That means this is what? This is opposing path. Okay. Once these thyristor 1 and 2 are triggered, okay, and there is a possibility of another path for this load current. Okay, what is that path? If current is flowing through this path, this direction, okay, if current is flowing through T2 and T1 direction, I0 current will flow through which direction? So this is IS current direction. Clear? If IS current direction, so what is that means? What does means? Means IS current is positive, and also and after alpha, Vs voltage is also positive. Positive voltage and positive current will give us what? So positive power value. Positive power means what? It is a delivering power to the load. Okay, that means the source is delivering power to the load, means it is supporting path. If you compare supporting path and opposition path, so current chooses to supporting path. Okay, so that is the reason why. So even though thyristor 3 and 4 were conducting, once thyristor 1 and 2 started conducting, so current chooses to this path. But the problem is these source inductance will not allow sudden change of current transition. So sudden transition from one set of devices, that is T3 and T4, and another set of devices T1 and T2, this will not happen instantaneously because of the source inductance. Inductance will not allow sudden change of current. Clear? So in that, so this is because of this source inductance, some amount of duration, these four devices will connect for certain duration. That duration is nothing but overlap period. Okay, so here overlap period, that is because of the source inductance. So previously, before alpha, direction 3 and direction 4 were conducting. Once direction 1 and 2 was given to the triggering pulse, at that instant 1 and 2 also started conducting, but the current is very much interested to flow through 1 and 2. This is because of it is giving energy to the load. But so previously current was flowing in this direction, so current was flowing up this direction, so from A to B in the inductor. So immediately once 1 and 2 started conducting, so current has to flow this direction, right? So from B to A. So but this inductor will not allow sudden change of current. Okay, so this transition from 3rd to 3, 4 to 1, 2 will not happen instantaneously. So at that some duration, that transition period is nothing but overlap period. In that overlap period, all the 4 devices are started conducting. Okay, that overlap period is, this is that overlap period. Okay, generally we call that overlap period is mu. Okay, so take this is overlap period. So for this is also, this is overlap period. Fine. Now, so in that overlap period, what is happening? So in that overlap period, so now if you take this I2 current magnitude, I'll consider that I2 current magnitude equal to IU current magnitude, that is overlap current. Current is started slowly increasing in device 2. Whatever current is flowing in this device, same amount of current will flow through I1 also, that is IU. Right, okay. If a current is flowing, this is I0 current, some amount of current is flowing through the second device. What is the remaining amount of current which is flowing through the fourth device? That is I4 is equal to I1 minus of this current magnitude will flow through the fourth device. That is what? I0 minus I mu. This is what the current flow through the fourth device. Whatever current is flowing through the fourth device, same amount of current will flow through the third device also. Reason is I3 and I4 are equal in magnitude. So this is I0 minus I mu current magnitude. Okay. Now before alpha firing angle, what was current flow to the supply? Before alpha firing angle, current flow to the supply, so current flow to the source is equal to minus I0 current. So that was minus I0 current. This is 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 equal to minus I0 current. Okay, so IS is equal to minus I0 current. So that is before alpha, less before alpha. Okay, after this alpha, from alpha, so let us take this stage 1. This instant is alpha plus mu. This is what instant. Up to this instant it was alpha angle, and if you add this mu angle, then we will get alpha plus mu. In this alpha plus mu, I need to mention one more parameter here. I3 current. Before alpha, what is I4 current? Before alpha, before giving trigger pulse to the 1 and 2 switches, I4 and I3 current is equal to the what? I0 current, right or wrong? So here this current is I0 current before that value. Okay, and what happening means at alpha instant I1 current is started increasing. I1 current and I2 current both are same. Okay, I1 current is started increasing gradually. Okay, if I1 current is started increasing gradually, what happens to the I4 current, that is I3 current? Okay, I3 current is started decreasing gradually, that is I0 minus I4, right? So it is decreasing gradually. This happens, this transition, current decreasing, current switching from I0 current to 0 and 0 current to I0 current. So this will happen within the duration that overlap angle. That angle is nothing but mu. Okay, within that mu angle, this transition will happen. Okay, that is from one set of devices, that is 3 and 4 to 1 and 2. Okay, but within this duration, what happens means all the 4 devices are conducting. Okay, so this is what that current magnitude. After this mu, this is alpha plus mu. After this instant, current flowing through the times to 1 and current flow to times to 2 also. That is, what is that magnitude? That magnitude equal to I naught current magnitude. Okay, and this current magnitude previously what it was, that was also I naught current magnitude. Clear? So fine. Now within this transition period, so if you clearly notice here, this is what voltage across this load. This one is plus and minus, so this is V naught here. This V naught at this overlap period, thyristor 3 and thyristor 2 are conducting, or else thyristor 1 and thyristor 4 are conducting. So in this overlap period, what happens means, if these two are short circuited, then V naught voltage is equal to 0 voltage in this overlap period. So you can directly draw here that V naught voltage is equal to 0 here. Okay, and then if you clearly notice, if we apply KVL to this loop, okay, from B to A and A to again X and X to B, okay, what you will get means, so minus Vs KVL to B, A and X, B path. If you take this path, and what you will get means minus Vs plus VL is equal to 0. That means VL is equal to Vs, supply voltage. In that overlap period, I am talking about overlap period, this overlap period. In this overlap period, VL, voltage across inductor, is equal to supply voltage. Only inductor activate only in that overlap period. Before that overlap period, what happens means VL equal to L into dA by dt. But here L into dA by dt. dA by dt means this I value is constant, current flow to inductor was constant. If that value is constant, then differentiation of dA by dt, so that is 0. That means this VL voltage is 0 in the normal operation. Okay, in except over this overlap period, in the normal operation, this VL voltage across inductor is 0 volts. This will activate only in the transition period. Okay, so fine. Now in that period, VL is equal to Vs voltage. This is what happening in that overlap period. So fine. Now what is this IS current magnitude? In that IS current magnitude, I1 minus I4 is what the IS current magnitude, right? So now let me write that one also. IS is equal to I1 minus I4. Clear? This I1 minus I4. What is I1 value? I1 is I. And what is I4 value? I naught minus IU. So that is I naught minus IU. So this is nothing but 2 IU minus I naught. This is what IS current, supply current. Okay. So previously this IU current was 0 ampere, so that IS is equal to minus I naught here. Okay. But at present situation, so this is 2 IU minus I naught at alpha IS is equal to minus I naught. Okay, but at alpha plus mu, what happens? At alpha plus mu. Okay, so I1 current reaches to what? I naught value. Okay, if I1 current reaches to I naught value, so here I reaches to already I naught value. So if you substitute here 2 I naught minus I naught, what you will get? IS is equal to plus I naught, that is I naught value. Okay, after that this I3 current become 0 amperes. Now in that case, what you have to draw means, in this period it reaches to I naught current magnitude. This is positive I naught. Okay, at what instant? At alpha plus mu instant. After this alpha plus mu, what is output voltage? After this alpha plus mu, current flow into the supply reach to I naught current magnitude, that is constant current magnitude. And at that instant, thyristor 1 and 2 are completely conducting, and 3 and 4 are stopped conducting. So if these two devices are conducting, then this current magnitude is constant current magnitude, and voltage across inductor is 0 volts. If current flow through inductor is constant current magnitude, then VL voltage will become 0 volts. So dI by dt value is 0 in that case. So now, if we apply KVL to this loop, that is B, A and X, Y and B, then we get V0 naught voltage is equal to supply voltage. Okay, until what instant? Until alpha pi plus alpha instant, until 3 and 4 will get triggered pulse at that instant up to this point. So V naught voltage is equal to supply voltage. Now let us draw that waveform here. Okay, so from pi plus alpha plus mu to pi, so alpha plus mu to pi plus alpha plus mu, V naught voltage is equal to same as supply voltage. And then same thing is happening here at alpha plus pi plus alpha plus mu from this instant. So here at pi plus alpha we got triggering pulse to 3 and 4 devices. At this instant what is happening you can directly verify here. At after pi radians Vs voltage is equal to negative voltage here, and Is current is its positive current. So if you multiply these two values, that is Vs into Is, then what will get? Negative into positive will get negative power, and instantaneous power. So Ps value is negative here. If this is negative here, it is source is absorbing power from the load. That means the source is behaving like an opposition path. From what instant? From pi instant to pi plus alpha instant. So in that case we need to create some supporting path to the load. So what we will do is we will give triggering pulse to 3 and 4 devices. If you give triggering pulse to 3 and 4 devices and current chooses to this path, so this path will become the supporting path in that case. Okay, so same transition things will happen from pi plus alpha to pi plus alpha plus mu. Now in that case this I1 current started decreasing to 0 and I3 current started increasing to same I0, and this current reaches to constant magnitude here, and this is current magnitude I0, and same thing is happening. So if these two devices are conducting, this current will flow through opposite to the supply current magnitude, so that is supply magnitude. So this is negative value here, and then this current is negative value. Okay, so this is negative I0 minus I0 current. Okay, and again 3 and 4 devices are conducting, and if you apply KVL to this path, okay, x, y and a, b and x in this path, V naught is equal to minus Vs. If it is minus Vs, then minus of minus Vs will be the positive value. So here this voltage is positive voltage. Okay, and this value is 0 in the transition period. So these waveforms continues for the rest of the cycles. Okay, so this is what happens in the case of source inductance. Okay, so in the case of source inductance, current transition from one set of device to another set of devices will not happen instantaneously. It takes some time. That time is nothing but overlap period. That period we call here mu will take. So in that duration, all the 4 devices are conducting in that duration. Okay, so that is the reason that we are calling this period is overlapping period. In that overlapping period, output voltage is equal to 0 voltage. Okay, and that overlapping period, VL voltage is equal to supply voltage here. And one more conclusion. So at alpha instant, at this instant, Is is equal to minus I0, and it is moving from minus I0 to I0 within this overlapping period. From alpha to alpha plus mu, it is changing from minus I0 to I0. Okay, source current is changing from minus I0 to I0 current. Calculation of overlap angle, calculation of this mu, calculation of this overlap angle is how we'll calculate. So it is the interval from alpha to alpha plus mu. I'm taking only this interval from alpha to alpha plus mu. In this interval, what is the situation happening in that converter? So complete transition is happening in this overlapping period only. So in that case, VL voltage across inductor is equal to the supply voltage, and the same thing Is current. Here the Is current is equal to minus I0 current here, and at alpha plus mu, Is current is equal to I0 current. So this is what the yes. Now VL is equal to Ls Is by dt. Clear? VL equal to Ls di by dt. So from this expression, now Dis by dt, that is equal to VL by Ls. We can write this expression. Now here VL is equal what? So VL is equal to supply voltage Vs. So Vs is what? Vm sin omega t. Now, if you write here Vm sin omega t by Ls is what? Dis by dt. Okay. If you take this dt value left side. So now dis is equal to Vm by Ls sin omega t and dt. Okay. If you take both side integration, in that case integral dis is equal to Vm by Ls, it is constant, and integral sin omega t and dt. Okay. Now I will integrate this side with respect to omega t. So I will multiply this here omega and divide it with omega. Okay. Now what happens means Vm by omega Ls, I am changing integration with respect to t to d omega t and integral sin omega t d omega t. Okay. So this is integral dis. Now we are calculating this angle within this duration, right? From alpha to alpha plus mu. If you apply limits for this, integration, that is from alpha to alpha plus mu. What is these limits? From at alpha instant. Okay. At alpha instant, what is this limit? Lower limit. At alpha instant, what is highest current magnitude? At the instant of alpha, highest current magnitude is what? Highest current magnitude is I naught current magnitude. Here this limit is minus I naught current. Okay. Now at alpha plus mu, at upper limit is alpha plus mu. At alpha plus mu, what is current supply current? Upper limit. At alpha plus mu, what is current magnitude? Plus I naught. So here it is plus I naught. Now integrate this expression, will get I naught minus of minus I naught, that is plus I naught, will get here plus I naught, that is equal to Vm by omega Ls. Okay. Sin omega t integration minus cos omega t. If we interchange limits and substitute, then we will get cos alpha minus cos alpha plus mu. Okay. So from this expression, what we can write? Cos alpha minus cos alpha plus mu, that is equal to omega Ls I naught plus I naught, 2 I naught. So 2 omega Ls into I naught by Vm. Clear? So we need mu value. So for that mu value, what we will do means we will take this cos alpha plus mu left side and this is right side. Then we will get, so cos alpha plus mu, that is equal to cos alpha minus 2 omega Ls I naught by Vm. Here Vm, you can also write this Vm in terms of RMS value, that is root 2 times of Vs, supply voltage. Okay, you can also use that expression, no issue. This is what derivation for overlap angle. Okay, so from this expression we can calculate this overlap angle mu. Okay, here what we can say that, so from this expression, if we increase I naught current, that is load current, so this mu value increases. Clear? So if we increase this I naught value and this product will reduce. If it is reducing, then this angle is increasing. If this angle is increasing, then what is increasing? So alpha value is constant. So what is increasing? Mu value is increasing. And at the same time, if we increase the source inductance value, even though means in that case overlap angle also increases. And if we increase the supply voltage, in that case this overlap angle decreases. This is what the relationship between overlap angle and remaining parameters in the converter. Let us get average output voltage for this waveform. So in this case, in this waveform, so these are the different cycles. So here the cycles are starting from alpha to pi plus alpha, and second cycle is from pi plus alpha to 2 pi plus alpha. Third is from 2 pi plus alpha to 3 pi plus alpha. So let us take interval that is from alpha to pi plus alpha. So here that is time period for one cycle is pi radians, and here alpha to pi plus alpha and V naught d omega. This is what the average output voltage expression, that is 1 by pi, and there are two intervals from alpha to pi plus alpha. One interval is from alpha to alpha plus mu, another interval is from alpha plus mu to pi plus alpha. Okay, now split this integration into two parts, alpha to alpha plus mu and V naught d omega t, and plus same alpha plus mu to pi plus alpha, again same V naught d omega t. Okay, now within this interval, within alpha and alpha plus mu, within this interval, what is V naught value? V naught value is 0 volt. So this is 0 volt. So now 1 by pi and V naught alpha plus mu to pi plus alpha, where V naught is equal to what? V naught is equal to supply voltage. Now here Vm sin omega t and d omega t. Okay, now 1 by pi, and this is Vm sin omega t integration minus cos omega t. If we interchange these limits, what we will get? That is cos alpha plus mu, okay, minus cos pi plus alpha. Okay, now cos pi plus alpha is minus cos alpha. So in that case, this is Vm by pi. This one is what? Cos alpha plus mu, and this is minus of minus, so you will get the cos alpha. This is what average output voltage expression, and we know cos alpha plus mu value, so directly substitute that alpha plus mu value. Here V naught, what is cos alpha plus mu? Cos alpha plus mu is equal to cos alpha minus 2 omega Ls I naught by Vm. Okay, if you substitute this expression in this, what we will get? V naught is equal to 1 by pi, so not 1 by pi, it is Vm by pi, and cos alpha and minus this term, that is 2 omega Ls I naught by Vm, and plus again cos alpha. Okay, now this is 2 cos alpha and 2 omega Ls I naught by Vm. If we multiply with that, then what we will get? V naught is equal to 2 Vm by pi cos alpha minus Vm will get cancelled, and minus 2 omega Ls I naught by pi. Okay, now this is what average output voltage expression for this converter with source inductance. So if you clearly notice, V naught voltage for source inductance, if source inductance was 0, Ls was 0, in that case what was V naught voltage? V naught voltage is equal to 2 Vm by pi cos alpha. Okay, now because of that source inductance, this voltage magnitude has been reduced to this value. This is the value. Because of that source inductance, this value has been reduced from the output voltage. Okay, that is also one drawback from source inductance.